Port of Southampton plays a significant role in the UK economy, supporting 45,600 jobs and contributing 2.5 billion to the UK economy annually. Within the port is Southampton Container Terminal, operated by Dubai Ports DP World. Handling in excess of 1.5 million containers per year, it is the second largest container terminal in the UK. SCT can accommodate the largest ships in the world with lengths up to 430 metres. The average size of container ship has doubled since 2006, with just 626 ships providing 36% of all the TEU capacity. Owners are continuing to build the largest classes of ships. The largest container ship in the world, the MSC Arena, has a maximum draft of nearly 19 metres. With such deep draft vessels operating in coastal waters such as this one, maintenance dredging is a necessary part of port operations. Dredging is the removal of seabed. Aside from aggregate dredging, the sole purpose of which is to harvest materials such as sand and gravel from the seabed for use in construction, there are three main categorisations of dredge projects: capital, maintenance and remedial. Capital dredging is when an area has not previously been dredged and is used to facilitate operational growth. Examples of this in the context of the Port of Southampton include channel widening and deepening, the instigation of turning circles, and land reclamation for port estate expansion. Shifting seabeds mean that over time, depths of water at capital dredge sites decrease. This necessitates maintenance dredging to ensure that the depths remain as advertised, the infrastructure investment is protected, and the waterways continue to serve as planned. Remedial dredging is for the benefit of the marine environment. It can include the removal of contaminated material dumped before more stringent marine pollution regulations came into effect.
I'll be talking about maintenance and capital dredging through the lens of the DPSIR framework. DPSR is a useful tool to analyse the root causes of environmental degradation. It stands for drivers, pressures, state, impact and response. Drivers: direct and indirect socio-economic factors driving maritime activities within the Port of Southampton and Maritime District. Pressures: motivated by drivers, these are the activities which result in a physical state change, in this case, dredging operations. State: the quantifiable change in environment. Impact: the effect of a change in state. And response: mitigation or prevention of negative impacts. Actions taken to promote sustainability. The maritime industry plays a critical role in global trade, but significantly impacts the environment. Key concerns include greenhouse gas emissions, pollution, and habitat disruption. The UK's Maritime 2050 strategy emphasises reducing these impacts through cleaner fuels and energy-efficient technologies. The Port of Southampton is pivotal in this effort. As one of the UK's largest ports, it faces environmental challenges, particularly from dredging activities essential for maintaining navigable waterways. Dredging can disrupt habitats and increase water turbidity, but adopting environmentally friendly techniques and regular assessments aim to mitigate these areas, balancing operational efficiency with environmental stewardship. The Port of Southampton has several key trades of ship: container, cruise, oil and oil product, roll-on, roll-off, ro-ro, and bulk and general cargo, including aggregate dredges. The development of each trade has its individual drivers, and whilst causation versus correlation can be hard to establish, comparison can indicate wider trends. From those, I've identified four key drivers: future-proofing and pace of development, the natural pressure of the movement of silt and sediments, and the growing demands of the population, and corporate and political pressure. The Port of Southampton has been in continuous operation since its foundation by the Romans in the 1st century AD, although there is evidence to suggest a port even before then. It was then known as Clausentum,
and developed to support the evolving import requirements of Britain's growing Roman population. The port has steadily grown in line with societal development and globalisation since its foundation. The foundation stone for the modern docks was laid in 1838. In the 1920s, the port was redeveloped to accommodate increased liner, ro-ro, dry bulk, commodity and fresh produce demand. This involved a massive land reclamation of 400 acres and a dredging project, vastly increasing the port estate by shore size and the size of the vessel that the port could service. These images illustrate the construction process and the changes to the port estate. A seawall was constructed spanning the Southampton Bay as it then was. Dredged material and concrete were used to fill the bay in and create the western docks. This was indirectly driven by the advancement in technology and the business practices making cruising affordable and accessible to more people, and by the end of World War I, promoting a national desire for leisure. The development was also driven by the technical and industrial landscape at the time, with increased mechanism making the process more manageable. In the 1960s, Southampton Container Terminal was built as one of Britain's first. Containerisation saw a massive shift in the way that cargoes spanned the world and were handled ashore. Ever evolving, in anticipation of future drivers, the port has continued to adapt to larger ships and shifting trends. In 2024, the western docks of Southampton were widened by 65 metres to accommodate larger container ships. This was done by dredging 900,000 cubic metres of seabed. Now, in 2025, the port is undergoing its latest £25 million development in Marchwood to handle a greater breadth and quantity of cargoes. The port must continue to evolve to fulfil its purpose and to meet societal demands.
The natural pressure of sediment movement necessitates dredging operations to maintain the build-up and redistribution of sediments in bodies of water. Over time, sediments accumulate due to the hydrodynamic forces such as currents, tides and waves, which can obstruct navigation and disrupt water flow. Erosion and deposition further contribute to sediment redistribution, requiring dredging to maintain clear channels and harbours. As the population increases, the demand for goods rises, leading to larger ships and a higher volume of shipping activities. This graph shows the trends between population growth and traffic volume in Southampton since 1982. To accommodate these changes, the port has expanded its infrastructure, including deeper berths, wider channels, larger cranes and improved logistics systems. This expansion not only facilitates the efficient handling of increased cargo, but also creates employment opportunities and drives economic growth in the region. The Port of Southampton serves as a prime example of how adapting to population growth can transform maritime activities and stimulate regional development. This graph shows the relationship between the gross domestic product, GDP, and Southampton shipping traffic. It's clear to see a trend of GDP and traffic correlating, which suggests a close relationship between the local maritime industry and national economic performance. Port operators can, and indeed do, therefore study economic forecasts to determine expansion plans. Large-scale socio-economic events can also be spotted by observing maritime trends. When we look at this graph of imports and exports alongside Southampton shipping traffic, the COVID-19 pandemic can clearly be seen owing to a drop in cruise passengers between 2021 and 2022. The port traffic recovered, however, in 2023, partly because of Brexit shifting Britain's global trading position to increase reliance on imports, and partly because of the uptake of cruises again following the pandemic. Dredging is a necessity created by the drivers previously mentioned. The exact pressure that dredging exerts on the marine environment depends on the method of dredging employed. All methods, however, produce turbid water. Turbid water can cause serious damage to the marine ecosystem in a variety of ways.
Restricting sunlight reaching the seabed hinders photosynthesis of aquatic plants such as seagrass. Suspended particles can clog the gills of fish, hindering their ability to breathe properly and potentially causing stress or mortality. When the sediment settles on the bottom, smaller organisms such as shellfish or insects can be smothered and buried, as well as fish eggs and larvae. There are many species that thrive in murky conditions of turbid water. Introducing turbidity where the water was previously clear can alter the structure of the marine ecosystem. The seabed is a hive of marine life and seagrass, which serves the ecosystem by providing habitat, photosynthesis to provide oxygen for aquatic life, and filters water to improve quality. Additionally, it works to capture carbon because of the photosynthesis process. The natural driver of water and sediment movement causes high spots in the seabed. Where ships navigate, this is a hazard and it must be addressed. To this effect, bed levelling is a process whereby the seabed is ploughed to facilitate a consistent known depth for navigators. It's done by towing a steel plough along the seabed behind a tug. Dredging and ploughing operations create noise pollution through machinery, dragging of suction heads and ploughs, and by disturbing the water. Since 1936, it's estimated that at least 44% of the UK's seagrass has been lost, 39% of that since the 1980s. This stark drop can't be attributed confidently to any individual pressure due to lack of data in previous years. It is acknowledged, however, that dredging, coastal reclamations, and building of seawalls, such as the project to build Southampton's Western Docks in the 1920s, contributed to the degradation of seagrass meadows. It's also acknowledged, however, that disease was the primary cause of the seagrass loss. The Department of Geography at the University College London have estimated that 11.5 metric tonnes of carbon could have been stored in seagrass meadows, which were lost since the 1930s. The same seagrass could have supported around 400 million fish. Salmon migrate from the River Test and through the Southampton Maritime District. There are several ways in which these salmon can be affected by human activities. Alteration of waterways affect the migration of salmon upstream, and dredging operations can hinder the natural flow and movement of the fish, impacting their life cycle and population. The environmental toll of Southampton's maritime operations is carefully considered and controlled. Every dredge campaign within the district is overseen by the Marine Management Organisation, which requires consultation with stakeholders such as Natural England. Water quality is monitored throughout dredge operations, with the provision to stop should the water quality drop below the prescribed limits. The Environmental Agency is a key regulator of water quality, with several key legislations governing dredging. The Environmental Act of 1995, the Water Resources Act of 1991, and the Environmental Protection Act of 1990. The European Union's Water Framework Directive establishes protocol for the protection of waterways. As a part of this, a river basin management plan is required. With regards specifically to the local migration of salmon, all maintenance dredging is stopped during the migration periods and the impact is carefully monitored. Capital and maintenance dredging, as part of the infrastructure development, is a vital function within the maritime industry. With ships set to get larger yet and volumes trending upwards, it certainly has a place within the future. Historically, little credence has been given to the environmental impact of these operations, resulting in habitat loss and damage to ecosystems. Now that the wider industry is more concerned than ever with sustainability, care is being taken to protect our waterways and move towards a more symbiotic relationship between the natural environment and human infrastructure.